risk. Right? So if we make $100 and we risked $100, our percent return is 100%. If we bet, yeah, so if we bet $10, made $100, our percent return would be 1,000. If we made $10 and bet 100, our percent return would be 10. So percent returns total profit divided by total risk. Um, okay, then total risk is just risk is equal to bet amount times num bets placed. Oh, so maybe we want to input a bet amount. No, that would be two different optimizers. But we could say, what's the final thing? Yeah, I guess that would be a machine learning thing. We could feed in the change in home odds divided by change in home odds and then also feed in change in away odds and then spit out how much money to risk. Okay, yeah. How much money to risk on the home team, how much money to risk on the away team, I guess. All right, total risk equals bet amount times number of bets placed. So percent return then is just total profit divided by bet amount times num bets. So if we want to reward So, I don't know. Let's see. Is my audio, did it just turn off? No, we're good. Okay, so wins is equal to, so let's say this is a two element tuple. Oh man. X train wins. Let's see if we could add those two lists together like that. So L1 is equal to 1, 2. L2 is equal to 3, comma 4. And then L1 plus L2. Yeah. Oh, let's try again. So L1, let's do two elements, 1, 2. And then the second element will be 3, comma 4. Let's make it a tuple. So it's the same as the data we're working with. All right, so L1 is equal to that. Oops. Then we could say L2 is equal to 5, comma 6, 7, comma 8. Okay. Then L1 plus L2. Nice, so that does do what we want. So X train wins is this list of zip wins 0, comma wins 1 plus, but didn't I just try that? List of zip wins 0, wins 1 plus list. Yeah, I mean, this looks like just what we want, so. All right. Okay, so X train wins equals that. So plus list of zip of losses 0, comma losses 1. And that is just our X train. NP dot ones, NP dot zeros. Okay, so we could say NP dot ones, and it should be the length of wins of 0. All right, plus NP dot zeros times NP dot zeros of, and we want it to be the length of losses of 0. Oh, NP dot one operands could not be broadcast together with shapes. Aha, NP dot ones plus NP dot zeros. So this, can we do two list dot two list? Okay, good. So we could change each of these to be dot two list. Okay, and then over here, dot two list, and we should be good. Okay, nice. So let's put that in here. Now, y train is equal to, oh, and these we want to make self dot. Okay, self dot. Y train is equal to np dot ones of length of wins, len wins 0, um, of 0. Close the brackets there, and then, oh, make it a list so that we can append them to each other. And then the second thing we want to do is np.zeros of length of the losses. So losses of 0, dot to list. Now we'll get a 1 if it's a win or a 0 if it's a loss. So we have our training data. Now, once we have training data, What do we want to do? Xmin, Xmax is the training. So we're basically just getting the maximum values from the training data. Oh no, we're getting maximum values to use from the random points in the distribution that we generated. So we have X train, Y train. Now let's get Xmin, Xmax, Ymin, Ymax. What's wrong here? NP? Oh, plus. Okay, now first you want to plot the data set. Um, so pretty sure we import matplotlib at the top. Yep. So let's go back to where we were, and do we want to plot stuff? No, we don't want to plot stuff if we have the classifier. Just plot the data set first. All right, let's skip that. Plot the training points. Skip that. Plot the testing points. Who cares? ax.setXlim. Okay. So that's all axis stuff. Now iterate over classifiers for name, CLF. CLF equals make pipeline. Okay, so we want to basically make a pipeline where before CLF, we're doing the standard scalar. Okay. Make pipeline. So we need make pipeline and standard scalar. And where do those come from? Make pipeline. Make pipeline and standard scalar. Okay. From sklearn.pipeline import from sklearn.pipeline import make pipeline. Okay, then we need from sklearn dot pre-processing import standard scalar. Okay, and the last thing we want to import is what? CLFX. So what are we still missing down here? Classifier. Where's the classifier? There we go. So classifier fit clf.fit. Okay. Now it should be self.xtrain, self.ytrain. Okay. Then score is how it does against the test data. And then plot the training points. And plot the testing points. Training points and testing points. But how do you plot the region? AX equals plt.subplot, CLF equals make pipeline, CLF.fit, score is equal to CLF.score. Then, decision boundary display dot from estimator. Okay, so we also want decision boundary display. Decision, where is that? decision boundary display. Ah, here we go. From sklearn.inspection. All right, decision boundary display. Now let's go down here, and then if we want to plot, oh, but that's all for plotting the region. So let's make a new function for plot classifier. Hands are getting sweaty. All right, now let's say, all right, plot classifier, classifier class, okay. Get classifier, classifier.fit. So we fit the classifier and then score equals that, so x.scatter decision, buddy, cut that out. So then we want to create a decision boundary display. So let's say define plot classifier of self, and then self dot classifier defined is equal to true, and then here let's say self dot classifier defined is equal to, this is not a function we need anymore, and we're going to set it equal to false because we're starting with the classifier not defined. And then here if self dot classifier defined is equal to false, then we're going to raise exception that says the classifier must be defined first. Classifier must be defined before plotting. Okay, now this is CLF, we should call it self.clf. And then also here, same thing, self.xtrain, self.ytrain, CLF. CLF equals k nearest neighbor classifier. So this we could also say is self.clf. It shouldn't make a difference. Okay, put it here, self.clf. Self.classifier defined equals true. So if classifier hasn't been defined, let's raise an exception and say, hey, the classifier hasn't been defined yet. And if it has been defined, then we could make a decision, or let's plot the data first. So we could say plt dot plot plt dot scatter, and we want to scatter self dot xtrain of 0 till, oh, of all and then 0. So every x element of xtrain, self dot xtrain. Okay, then let's get the y elements of xtrain. And then c equals ytrain. What's that? Oh, c equals y, self dot ytrain. So that'll just change the color depending if it's a win or a loss. And then, yeah, let's just do the same thing so it looks nice. Copy. All right. CMap equals CM bright. Import CM bright. CM bright. Oh, I don't really care. The color map looks pretty, so let's get that out of there. Okay. So we're scattering our data. Now we're setting our data limits. So plt.xlim the limit of the x data is from, okay, so here we need to add in self dot to each, self dot x min, self dot x max, and then self dot y min, self dot y max. Then xlim is self dot x min, self dot x max, and then the y limit is obviously just from the y minimum, self dot y min, self dot y max. Okay, so we've set our limits. Now set ticks. That shouldn't matter. Oh, I guess we want ticks. Well, whatever. Let's get it. Okay, whatever. PLT. Leave it. Who cares about the ticks? Okay, so then for each classifier it does this. Now, so we've got our plot. Now let's say decision boundary display. Decision boundary display dot from estimator, and we want to do self dot clf, self dot, so this we should make self dot x and self dot y. So self dot capital X, self dot y, and then range, and this has to be self dot x plus equals 2, and this should be self dot x dot shape. Now this should be self dot x and self dot y. Okay, anything else? Oh yeah, lots of other stuff. Self dot x, self dot x, and here's self dot x, self dot x. Make pipeline, Y train. Okay, so that seems to be working fine. Now, so xlim, ylim, self dot capital X. Don't care about the color map alpha, so that'll set the transparency. Just use the same thing, EPS. I don't know what that does. EPS extends the minimum and maximum values of X for extends the minimum and maximum values of X for evaluating the response function. Okay, EPS equals, we'll just do the same. Okay, so then we get the decision boundary display. We've plotted the points, plotted the training points, plotted the testing points. And I guess we want training and testing points to be over the decision boundary display. So we want to send that line first. Oops, copy it, and then put it in before we scatter. All right, now let's do our plotting. We've got our plot limits. Xlim, Ylim, Xticks, Yticks, x.text. Okay, so that's actually all we need. Now I just need to do plt.tight layout and then plt.show. Okay, so now let's do test classifier. All right, so put that down at the bottom. Test classifier is equal to 0. Now, if test classifier is equal to true, then we want to say C equals classifier, and then C dot get classifier of seasons. All right, so little c is equal to classifier. All right, then C dot get classifier or get seasons. C dot get classifier of seasons, right? C dot get classifier of seasons is equal to np.a range from 2007 through 2022. So that's just all our seasons, and then dot to list. So now we have the classifier. Then let's just do plot classifier. C dot plot classifier. And that should be good. Now take off everything else, and let's put test classifier equal to 1. Now let's run it and see how that classifier does. So get out of there. All right, save it and run analysis 1. C dot, oh, oops. Didn't mean to put that empty list in front there. All right, save, run again. Cannot import name standard scalar from pre-processing. Standard scalar, where was that? sklearn.preprocessing import standard scalar. Python 3 from sklearn. So we're trying to figure out how to get that package, or get that class, because we're failing at importing the standard scalar class. Cannot import name, whatever. Let's just look that up. Okay, so sklearn cannot import standard scalar. Huh. sklearn import preprocessing. Oh, from sklearn dot from matplotlib.plyplot. Okay. Oops. So we could just say scalar, standard scalar. So we should say preprocessing dot standard scalar. So when we call standard scalar here, say pre-processing dot standard scalar, pre-processing, and then back up to the top where we import stuff. And then from, all right, so from sklearn import pre-processing. Okay, does it work with that? Let's exit out of here, run the file again. List indices must be integers or slices, not string. C.get classifier. In get classifier, it says wins, losses, win odds, home odds is get analysis. List indices must be integers or slices, not string. Win condition. List indices. So it says that df is a list. Now how did that get changed into a list? Let's put the debugger in there. I don't even see what I could have changed to make it a list. Save it. All right, let's run it. Now, why is it a list? So df, df is a list of seasons. Get analysis. Oh, so seasons. All right, so where do we call get analysis? So instead of passing in df, we're passing in seasons. Oops. So let's find get analysis. Okay, so we're passing in data. Data equals self.training data. Oh no, that's not where we want to get analysis. We want to get it inside of the classifier class. Oh, okay. So we want to get analysis of self.df comma seasons. Okay, that should work well. Let's take out the debugger lines from get analysis because we don't want to be tripping ourselves up there. Oh, hey. Hello, Mypa Marie. Hi, Mypa Marie. Sorry for not seeing your comment. I was concentrating. Trading. All right. Thanks for watching, Mypa Marie. All right. Now we're looking for get analysis. Oh, we fixed it. Okay. So let's get out of here. Oh yeah, we commented out our debugger line, so we should be good. Now let's run that again. See what it does for us. Listening to see same thing. So does that again when we're doing win condition or losing condition. So let's put that back in there. And what does data frame look like? Okay. So what was the problem we had again? Type error, list indices. Oh, plt.scatter. So self.xtrain. Okay, so let's go look at what the xtrain data looks like now. Classifier. So before we scatter it, let's say put it in there, and what's it look like? Let's go look at the data. Oops, don't want that. Save. All right, now x self dot x underscore train. Oh, all right. Um, throw that in there. Okay, now self dot x train. uh, all to 0. List indices must be integers or slices, not tuple. Is that a tuple? Huh. All right. So x train. So we basically want to get the values of x train. So we could say I of 0 for I in self dot x train. And then let's remember what the last one is. So it should be 48 for the last value that we're looking at. Yep. So that looks good. Okay. So then let's say I of 0 for I in self dot x train. Or let's just say when we define x train. Okay, so self dot x train, we're just gonna make it lists instead of tuples on the inside. So we're gonna say, what if we try to turn a tuple into a list? Oops. So what if we try to turn a tuple into a list? Self dot x train of 0. All right, now if we try to make that a list, cool. So self.xtrain is equal to list of, oh, self. Okay, so here we have tuples on the insides. And then here we can just say, make the whole thing a list. No, that won't work. We have to do self.xtrain. We have to do it element-wise, basically, using list comprehension. So let's do self.xtrain equals I for I in self.xtrain. And what do we want to do with the i's? Well, we just want to turn it into a list. Okay. So that should fix our plotting problem. Hi, you can convert. Oh, nice. This is great. This is what I've been waiting for, some advice. Convert xtrain it to np.array. Oh, oh, okay, nice. Nice. Thank you, Maxime. Oh, great. Thank you, Maxime. All right, so thanks to Maxime, we have a faster way to do it. The lists will slow us down. So, oh, what's in an array? List of I. Oh, so I wonder if I could just do nd array. Self dot xtrain equals np dot nd array of self dot xtrain. All right, now let's get out of here. Oops. Self dot, we could just test if it works here. np dot nd array of self dot xtrain supported dimension for an nd array. Huh. I don't know. That confuses me. So let's take this off and we'll just use that because I know that it should work. And then we can, if we need to speed it up later, we can. Now let's run it. Plotting should work. Oh, oh, same problem as before. But we have list of I for I and self.xtrain. So if we go into here, this is the same format it's in the other file. Self.xtrain is that. It's just a list of 2-item lists. Oh, thanks. Thanks, Maxime. Of self.xtrain. Oh, cool. Maxime, you're making my life way easier. Thank you. Oh, that's why that wasn't working. Xtrain cont isn't a thing. Different sizes. And scatter? Okay, why are those different dimensions? Thanks, Maxime. Okay, so why are these different dimensions? Self.xtrain all 0 len. All right. Oh, so if we're doing all till 0 and 0 to all, what'd they do here? No, that was wrong. Pre-processing standard scalar. Okay. Oh, nice. One, you need to plot x in. Oh, that was backwards. Oh man, thank you. Okay, now this should work according to Maxime. Save it, run it. Oh, hell yeah. Now, what the hell is this? I don't. What? What? Why is there only? Oh, cause the okay. So now I need to figure out about that randomization. Um, all our random points are drawn from -2 to 2, but we have a way bigger range of our data. So I guess we should go from like -1,000 to 1,000. Oh, that looks cool. Yellow and purple. Um, -750 to 1,000. Yeah, so instead of 2, let's try here. Random state, and we're going to say 1,000 instead of 2. Now, does that work? For a whole range instead of just a small range. No. N features 2, N redundant, N informative, random state equals 1, range equals, so 2 times the range, then let's do 1,000 times the range. And this is probably just fine as 2, because that's just setting the random state. Okay. Oh, nice. Now this should work, I think. Oh, but now we're going from 0 to positive 1,000. So we want to go from -1,000 to 1,000. Okay, so let's look over here. We want to go from -1,000 to 1,000. Okay, let's just put this in, yeah, let's put this in. We could just mess around with this in the terminal to see if it does what we want. So get that out of there. Python 3. All right, now import numpy as np. Then we're gonna do r equals np. Oh yeah, r equals np dot random state, and we'll just make it the same as it is in our file. So 2. Numpy has no attribute random state. Oh, all right. np dot random state. Oops. Lowercase random dot random state of 2. Okay, then we could just do 1,000 times r dot uniform size is equal to x dot shape, so just 10. Okay, so that gives us a value r dot uniform of 10. So that gets us just a guess. Self dot x, self dot y. Oh, so it adds 1,000 plus range dot uniform. Oh, so we're doing 1,000 times. So, but from this range, the range is from. Oh, so if we're saying r dot uniform 10, then it gets us values from 0 to 10. Right. So range dot uniform. Oh, r dot uniform. Right. So we do uniform and the size. So that doesn't generate n number of data points. That generates something between 0 and 10. So r dot uniform of 10, and then we do minus. So minus whatever the shape is divided by 2. Okay, cool. So range dot uniform size equals self dot x dot shape. So that gets us a uniform item somewhere in the size of the shape. So what if we just do minus self dot x dot shape divided by 2. And let's try running that again. Tuple and int. Oh, self dot x dot shape. All right, the shape of x. All right, let's put the debugger in here again and figure out what the shape of x is. Self dot. Did this not save? Then let's go look at self dot capital X dot shape. 102. So self dot X. So why is it? Do we pass the data in here? No. So self dot X dot shape. Okay. So now we want to go into Python and we want to see what if we're passing a tuple as our argument. Okay. So Python now r.uniform of 10. So instead of r is equal to that. So then r.uniform of 10, but instead of that, let's do 10, comma 2. So now that's basically getting us a point between 10 and 2. Oh, that gets us a point between 0 and 10. Each value will be between 0 and 10, and it gets us 2 points. So we want to get 2 points, but every value should be between... What values do we want to make it between again? Run the file. I think like plus minus 500. So plus minus 1,000, plus minus 2,000. Those points are kind of outliers. Yeah, we could just do plus or minus 1,000 each way, I think. Or why not do plus or minus 2,000? So minus so the size we should say is a tuple, and it should be the first item in the tuple should be self.x.shape of 0, and that should be fine. Self dot okay, Okay, so size is self.x.shape. Now we want to subtract our value from each. So Python 3 analysis 1.py. Now self dot all right. So range dot uniform of self dot x dot shape. All right. And what if we do that minus 1000? Oh, great. Nice. So uniform self.x.shape and then minus 1000. Okay, so it's always getting, oh, duh. 1000 times range.uniform. Nice. Oh, nice. Thank you. So we can set low and, man, Maxime, you're the man. All right. Now that one's pinned. Thanks, Maxime. So we could set the range of uniform. Where is that again? Oh yeah, uniform size equals that. Low equals that. Oh yes, nice. So low is equal to minus 1000. High is equal to 1000. Now we could oh, that's it. Let's just take out this line, save it, get out of here. Now let's run the classifier, get it to plot. Whoa. Oh. Duh. Get out of there. Now one more time. Great. Nice. So we do a good job of isolating that. I guess I don't want every region, but this might work. Okay. Now we have to figure out how to get the points around the classifier. Minus 1000. We may as well go plus minus 2000, right? To get all the points. All right, let's run it. Cool. All right. So now what does the output of this look like? We want to take the output and draw around, basically get these yellow regions. So let's go back here and let's look at what it returns. Thanks, Maxime. You too. You made today much easier for me. Okay. We will now pin Maxime's new comment. Thanks, Maxime. All right, so what's the output of this look like? Classifier. So what we're plotting, all right, decision boundary display, classifier X. So our classifier is kneighbors classifier. So let's figure out what kneighbors classifier returns. Oh, it's a class. Right, of course. So attributes is false when y's shape is in n samples from sklearn.neighbors. So we've fit it. Now I guess we predict whether a point is going to be in there. Dot fit returns the fitted k nearest neighbors classifier. So it returns a classifier, k neighbors classifier, k nearest neighbors classifier. Oh, we could do regression based on k nearest neighbors. Well, we'll leave that off for now. Neighbors equals k neighbors classifier. So new.fit. And we do a prediction. So let's add a function here for testing the classifier. Test seasons should be a list and it defaults to 2021. Now wins. All right, put that there. Wins, losses, win odds, home odds. We need to add self as an argument. Self.df and then seasons. It should just be test seasons. Okay. Now we have that. Now what do we want to do? For okay, so assess profit. How do we get the profit up here? I just want to copy that and put it down below. Test region type, get region, self, region params of dict, region type is triangle. Plot region, get bets in region. Region bets dot append. So I guess we want to see what the data looks like. If we make a prediction, what's it spit out? So let's just say for test classifier, wins, losses, win odds, home odds is equal to that. And then we have, let's see, for win in wins. Again, what does wins look like? Oh, it's a two element tuple. Each element is a pandas series. So for win, it's a two element tuple. Each element is a pandas series. So for win in wins of 0 dot values, and then comma wins of, yeah, let's just look at our zipped list. Zip, zip, zip. Okay. So that puts everything into a big list. Get training years, test classifier for win. Oh, for home swing, away swing, in this So for home swing, away swing in there, print home swing, away swing. Now when we do the classifier, let's add test classifier to the bottom, c dot test classifier. Okay, then let's run that and see if our test works, and we're printing out each of the bets in our test season. Okay, exit out of the plot. Okay, so that works. We could just say, yeah, that's fine. And then we're gonna want to say prob. So the win probability is whatever. So we're returning that, then predict. So we want to win probability is predict. Oh, so we have to do the classifier. So win probability is self dot classifier dot predict, and we want to predict the point that's defined as the away swing minus the home swing. Well, away swing, comma, home swing. For home swing and away swing, zip wins of 0, wins of 1, plus list losses of 0, losses of 1. What? For home swing, away swing. Does this look right? Okay, then I'm going to say, let's put the debugger in here just to make sure we're training and classifying on the same thing. All right. Expected 2D array. Classifier.predict np.array of away swing, home swing. Now does that work? Exit out. Cannot interpret 110 as a data type. Oh, well, we could just predict for the whole list. Win probs equal. All right, now that we could back up. And the for loop line we can delete. Run that again. Exit out. Away swing is not defined, right? Because we want to use that zip functionality. Now, let's put the okay. So we want to zip. Let's just put the whole thing in here. And then here we want the debugger because we want to see what X train looks like. So let's run that. Okay, self dot xtrain. Okay, so the last point in xtrain is 45 minus 39, which should be scatter win probs. Win probabilities, whatever. plt.show. Oh, let's get out of here, out of the debugger. Oh, so we get a problem with the scatter. Okay, let's just do plt.plot win probs. Okay, now let's run that. Exit out of that. Nice. So the win probability seems like it's almost always 1 or 0. Okay. Now, test classifier, plot classifier, get classifier. So now we can make a new function called test classifier seasons. And this is going to do, so test classifier seasons, and we want to pass in what test seasons to use. Is equal to 1. And then let's just, or whatever, it doesn't matter what that is, so long as the format makes sense. And then we want to go to test classifier, and that was just to check if the classifier looks good. Now we want to, okay, so we have a classifier. Now assess get bets in region, assess region. Now, oh, we already have that. So wins, losses, win odds, home odds. Now for win in, so for win and wins, what did we do up here? Get region, plot region, get bets in region, assess region. So for item in region wins, if np.isNaN of item.any is equal to false, if item of -1 is less than 0, for item in region ones, if, okay, so if the final item for item home odds, wins, losses, win odds, home odds? What? Return, wins, losses, home close odds. Oh. Win odds and then lose odds. So not home odds, loss odds. Now for win in wins, so for C win in enumerate wins, we can say the probability is equal to win probs of C. Now if prob is greater than 0.995. We want to place the bet. So for each win and enumerate wins. All right, so place bet is equal to true. So now we're just gonna say by default on each win, place bet is equal to false. And then if our probability is high, then we're going to place the bet. Now, actually, get rid of that. We don't need that place bet variable. We could just say if probability is over 0.95, we're going to place the bet. Now, standardize our bet amount to 1. And then if probability is equal to 0.95, is greater than 0.95, we're going to place the bet. So we're saying if win odds of C, not 0 of C. So if win odds of C are greater than 0, so if the odds are positive, then return is equal to win odds of C. So if the win odds are positive, should be bet amount times win odds of C divided by 100. Now, that's how much we get if win odds of C are greater than 0. So then we could say else if team is favored, if home team is favored, what do we do up here? So assess region if for item and region wins, region wins equals get bets in region, my wins region. So just return the bets. For item and region wins, bet return equals absolute value of bet amount times, all right, we could just say this. So our return is that, otherwise do that. Bet amount divided by 100 times the odds, okay. Then profit plus equals bet return. Okay, so, all right. Now, otherwise, if the home team is favored, the return looks like what we just copied and pasted. Win odds of C, so instead of item of -1, we do win odds of C And so now we have our return. If probability is greater than 0.95, our return is defined by how much we're winning. If probability is less than that, we're just not going to place the bet, and then return is 0. So here we could say total return is equal to, bet amount we should put outside of the loop. Copy, get out of there, put that here. Now we're going to say total return is equal to 0. And then if probability is greater than 0.95, we're going to want to add to our total return, whatever the return is, plus equals ret. All right. So for each win and enumerate wins, we add to our returns. Now we need to do for each, so then we could just say total return plus equals minus equals len of losses. Because it doesn't matter what the losses are, we just lose our bet amount. Bet amount times, see if that makes sense in Python, a equals 1. 10 times len of a. Len of a is 1. Oh. Okay, that works. So 10 times len, so bet amount times len of losses is how much we're subtracting. Then we're going to print. So here let's print total return. And then once we subtract bet amount times losses, now we want to print. Now, len of losses, how many losses do we have? And then also total return. So then we want to take out the bet amount for each loss, and we get the return. Now, is it doing test classifier in here? Test classifier is equal to true. C.test classifier, cool. Now let's exit and run the file. Cool. Now is it going to print out our money? No. Win odds of C is greater than 0. All right, now we got to go see what win odds of C looks like. For C win, so win odds of C, let's put the debugger in here. And let's go look at win odds. Exit out of there, let's go see what win odds look like. Oh, really? Poor Ivy. I don't know. It depends what. Yeah, she should be. She should be. Yeah. Gross. So if win odds of C is greater than 0, return win odds of C. So win odds dot. Here, we'll just say win odds is equal to win odds dot values. Continue. Let's run that again. Now we should be good. Exit out of the plot. Continue through there. Test classifier. Why? Oh man, it's going to do that for each win, which we don't want to do. So we're going to have to exit out of here. And here, we could just continue out of there. Oh, that's stuck in a loop too, I think. Yep. Right, so exit out of there. Now here, we can go and let's run that. Exit out of the plot. Okay, and that works. So what did we return? Test classifier on 2021. Get classifier. And what were the seasons we used? So seasons should be 2007 to 2021. So we don't want to classify for including 2021. And then two thousand seven, 2021. get training years plot. So print how many losses there are. So there are 2 losses. Okay, let's just put the debugger in here because we want to look at what did it do. Now let's see what the win probs look like. Okay, win probs are always a 1 or a 0. Now ones are wins, right? Length of wins, np.ones, length of wins. Yeah, so 1 is wins. And then xtrain does wins, and then we do losses. So yeah, so ones are wins. So, okay, for cwin, print total return, win odds, wins, length of wins. But we're only doing 2 wins. For cwin, in enumerate, list, enumerate. For cwins, in enumerate, list, zip, wins of 0, wins of 1, boop, boop. All right. Now, does that work? Let's see. All right, now, len. Let's just continue. There's nothing to look at there. Okay. So for C home, now wins of 0 is away swing, right? Wins of 0 is away odd swing. Wins of 1 is home odd swing. So if we go down to the classifier, so for C away swing, home swing, list, zip, wins 0, wins 1. So for C, away swing, home swing, and enumerate that, prob is equal to that. Win odds of C. Yeah. So does this work any better? We basically don't want those nan values. I don't know why we're getting nan values. Not enough values to unpack. Expected 3, got 2. So for C, win. So for C, win in this thing, do we ever reference win? No. Continue. So total return is nan. So let's, for cwin and enumerate wins, get our prob. Now let's print away, win of 0, win of 1, and then we want to do the probability. Now, how does that data look? Is there anything weird going on? Exit out of there. So we're printing win of 0, win of 1, and probability. So you have a whole bunch of wins. Oh, now let's total return. plus equals return. So something's going wrong when we're printing the return. So total return, and then we want to do print odds, print, did I copy that? Nice. Win 0, win 1, prob, and then total return, and then win probs of C. Ah, I bet it's in how that win probs is formatted. So if we go to win probs, no, that looks fine. Okay, so let's continue, get out of there, and then let's plot it. Or sorry, run the file again, and we need to get rid of the plot. And then now we're here. So for each one we're printing win of 0, so away swing, home swing, away swing, home swing, probability, away swing, home swing, probability, prob? Oh, we don't want win probs, we want win odds of C. Duh. Win odds. Oh, so win odds has nan values in it. Now len of win odds, length of wins of 0. So win odds, we didn't do drop NA. So down here, wins, losses, df of, oh, right, so dot where win condition, and then we want to drop the nan values. Dot where lose condition, dot drop the nan values, drop nan. Let's go through there and see what that looks like. Exit out of the plot. Nice. Continue. And what am I printing at the bottom? That 57, what's that, 255? Oh, because the loss thing we're still doing wrong. So length of losses of 0 is what we want to subtract. All right, get out of here. Okay, now, all right, that obviously performs poorly. Minus equals bet amount. So this is if we're betting on each one. Now, what if we want the classifier to return probabilities that aren't just 0 or 1? Predict the class labels. Oh, so we don't want class labels. We want predict the probability. That's pretty different. So prob equals win probs of C. So win probs. So it should be predict proba. Okay, now we could just take when the probability is greater than 0.95. Okay, should turn that plotting off. Let's say plot classifier and add one that's show equals show is a bool that defaults to true. Here just say if show is equal to true, then show it. And down here when we're testing it, we're gonna say show equals false. And then also here, in case we forgot to clear the previous, we can say clear it. Okay. Now what's that look like? Did I already fix that? Plot classifier, if prob, so win probs is equal to that. Now prob equals win probs of C. Predict proba. What does that return? Need to put the debugger in here. Let's figure out what win probs looks like. All right, what does win probs look like? Huh. So, oh, I guess that's the probability that it's classified as 0 or 1. Bro, I'm the only one in the stream and don't even know how to recode. Why did this? Hahaha. Probably because coding's fun to watch. It's aesthetic. You're just kind of slowly building something. Um, and it doesn't take, you don't need any money. All you need is a good attitude. Um, that's why I like coding. That's why I think it's aesthetic. That's funny though. Okay, so basically this is classifying the probability that it's a loss, and I think this is the probability that's win. So if prob of 0 is greater than 0.95, let's place it. So continue to get out of here. Now let's run it and see what it does. Now we want to comment out this line because we don't really care about it. And I think we could comment out that line as well. Save it, take off caps lock, and get out of here. All right, so that returned minus 104. Now, I'm not sure if it was saying that prob 0 is a win or prob of 1 is a win. So now let's say if prob of 1 is greater than 0.95, let's place the bet. And not much of a difference. We had 28 before counting losses there and 26 before counting losses here. So with this strategy, we're taking every bet that is in the data set if the probability is greater than 0.95. If prob of 1 is greater than 0.99, let's place it. So I'm trying a different value to test for. Yeah, that doesn't help at all. Okay, so let's go to our Trello board and see where are we at. So we've added classifier to the code. All right, added the classifier. That is done. Now clean up code, we could do that later. Now what we want to do is generalize classifier so that we can use different types of classifiers as well as different parameters. So we want to mess around with the parameters and say, hey, if we keep tweaking the values of this classifier, do we get an algorithm that consistently returns money? Now let's document this in PowerPoint. So let's plot the classifier one more time. Go down here, plot, so show, show, instead of false, we're going to say show is equal to true. So we can put that into our PowerPoint. Open up the PowerPoint. Okay, don't know what that is. Then let's get that plot. with our snipping tool. Okay, let's take that, throw that in there. Where do we want to put it? All right, testing classifier region. And oops, we want to put some text in. So let's put the classifier plot over here. All right, then let's add some description. Okay. Why won't that change? Okay, whatever. Just gonna copy that text box, put it in, get rid of this one. All right, classifier implemented nearest neighbors classifier. And now we should probably go make the plot look the same as the plots we're looking at on the example. So we want to say, we want to get that text on there. So iterate over data sets. So we're going to want to add a Boolean for whether we want to plot the results or not when we do the test classifier. So test classifier plot is a Boolean that defaults to true, I guess. Or probably should default to false because we probably don't want to look at the plot too much for this. Now, okay, so then we have this whole thing, then we say if plot is equal to true, then we're gonna plot that classifier again. Okay, so if plot equals true, plot that classifier again. Then wins, losses for, okay, so first we want to plot, we want to scatter this. All right, plt dot scatter, so go ahead and scatter the wins and losses. Actually don't want to zip it or list it. We just want to scatter the home swings versus the away swings. Oh yeah, away swings come first and then home swings come. And then label is equal to test data. Okay, and then plt.legend. Okay. All right. So now we want two lists. We want to get one list for placed wins. So that'll be empty. Then we want to get another list for losses that we've placed. So both empty list. Okay, now for C win, so for each win, we want to get the probability, then placed wins dot append. Oh no, that's right. Prob of one, prob equals win probs of C. For C win and enumerate wins, then we're going to want to append to placed wins. For win and each win, placed wins dot append win, and then we're gonna say so we're gonna print and then subtract losses from the total return, and then we're gonna say for loss in enumerate, no, don't need to enumerate, just for loss in list zip losses of 0, comma, losses of 1. So for each loss, we're going to say place losses, dot, oh. Okay, so now we need to, because we're not evaluating this, right? So we need to say for loss in list zip losses of 0, comma, losses of 1. Oh, so that's why it's performing poorly, because we're automatically taking every loss. So if now we're going to say prob is equal to win probs, oops, no, win prob, oh yeah, win, whoa, ah, oh, what? Oh, proba, yes, so that gets all of the probabilities, but we don't want all of the probabilities. We just want the wins. So for each win in wins, okay. So these are the wins for the season and the losses for the season. Now the win probabilities, for C win and enumerate wins. So the win probabilities is longer than wins. So win probs we could just make equal to that. Now that won't change what we're currently working on at all. But then down here, we could say loss probs is equal to self.clf.predict proba, and we want to predict the probability of list of, oh, we already have the thing we want to predict, so just take out that plus sign and we'll be good. All right, let's save it. Now we have loss probs, so for loss in all losses, prob equals loss probs of C. Now here we need to do C, comma, loss, and enumerate this list over here. Now prob equals loss probs of C if prob, so loss probs of C. Now if prob is greater than 0.99, if prob of 1 is greater than 0.99, otherwise if prob of 0 is greater than 0.99, then now what I just don't remember what order we put it in. It doesn't really matter. Now if prob of 0 is greater than 0.99, oh, if it's high probability, it's a loss. Now if prob of 1, no, prob of 0, no, we should just say if prob of 1 is greater than 0.99, then what we want to do is say total return minus equals, so decrement total return by bet amount if we place the bet. If we don't place the bet, nothing happens. Now placement threshold is equal to 0.99, and this is the probability threshold to place the bet. All right, now if prob of 1 is greater than placement threshold, then do that. And then for the losses, if the probability is greater than the placement threshold, and go do that. Now, save it. Now let's see what that does. Exit out of this plot. All right, now this we can print len. We just want to print total return. So let's print it before it gets the losses, and then after it gets the losses, let's print total return. Okay, let's exit out of there. Okay, so now we're cooking. So let's try changing the placement threshold to be 0.95. Okay. Okay. Now, okay, so we've been assuming that 1 gives the probability of win, but it could be 0 gives the probability of win. So let's test that. That doesn't really help much. Okay, so what's a 0 and what's a 1? So the categories, what are the categories? N features 2, so there's 2 features, no redundant features, no informative features. Oh, we're also using the same number of clusters per class. So self.x train xmax. So x train list of I. So wins of 0, wins of 1. Yeah, what we're trying to figure out what the shape is. So we have X and Y as the shape, but what about the shape of the classes? There are 2 classes, but how do we figure out which one's 0 and which one's 1? And which one's win and which one's losses? Y train equals np.1s. Okay. Where do we ever make the 2 classifications? So get classifier, linearly separable. So the y is the 0s and the 1s. Self.y, make classification. So where do we mess with y again? Y train is 1s. Xmin, Xmax, classifier. Yeah, so what about, we gotta look in classifier and see which one's which. Now, probability. All right, so we're here now. Let's do get proba, score, predict the class labels for the provided data, return probability estimates for the of shape n queries and features or n queries index. So the array returns returns n queries. So it's n queries wide by n classes. Oh no, n classes wide by n queries deep, or a list of n outputs of such arrays. if n outputs is greater than 1. Class of probabilities of the input samples. Classes are ordered by lexicographic order. What is that? Lexicographic order. Mathematics is a generalization of the alphabetic order of the dictionaries to sequences of ordered symbols or elements of a totally ordered set. So what would it be in order? What? 1, 2, 3. Oh, so reverse lex, reverse colex, lex. What? Which label is which? So we could, let's just train on 2021, get classifier, seasons is equal to 2021, and then we should classify on it. Now, if we're using the right data, we should return a profit because we're training and testing on the same data set. If we're using the wrong data, we should return a loss. Okay, so that's a loss. We didn't place any bets, we only took losses. Now let's go back to here. Classifier. So instead of using prob 0, we want to use prob of 1. So the probability that it's a win. Now let's see what it does. Nice. Okay, so we know we're looking at the right probabilities. Now let's put this back in. All right, so all right, now for season in np.arange of 2008 to 2022 dot toList. So we're going to get each season in here. Then we're going to do, get out of there. All right, so for each season, prev years is equal to np.arange of 2007 to season minus 1. Let's make sure that makes sense. So we're going to do import numpy as np. What? Oh, import, not impot. Import numpy as np. Then we're going to do np.arange from 2007 to 2007. So not season minus 1. We just want to go till season. So 2007 to 2008 should just be 2007. Cool. Dot to list. Then classifier, c.get classifier, seasons equals seasons is equal to previous seasons. Seasons equal prev years. And then plot classifier show equals false. And then test classifier should return a value. Test classifier now we're going to say return total return. All right. Now let's go down here. So returning that value. So total return is equal to that. Then now returns is equal to just an empty dictionary. Now for season in that, returns of season is equal to returns of season is equal to total return, and then we could say PD, so df is equal to PD. We could just say data is equal to pd.read, no, pd.dataframe. And the data frame is just going to be our returns dictionary. And then data, so now let's save data to a CSV. First, let's say data dot set index. So we want the index of the data to be whatever the seasons are. So here, let's just copy this. We're going to say seasons is equal to this thing. My seasons is equal to that. Now data.toCSV of my seasons is equal to that. Oh, set index. Returns of season. Oh. Okay, just make returns a list. Now returns.append total return. So add it on to the end. Okay, now we've added our total return. Now we want to do, so we have our returns. Now data equals pd.dataframe, and then it should be year, my seasons, and then returns should be returns my, now this needs an S, seasons, returns is returns, data.set index, the index should be the year, and then data.toCSV classifier results .csv. All right, that should be easy enough. Now we're doing it for seasons. Let's do test classifier. Total return equals c.test classifier. Test classifier, where's the plot? Test classifier. If plot is equal to true, then do plt.show down here. Now, here do plt.ca, clear it up. If you want to plot it, then plot it. Nope, don't want to go in there. We want to save this. Then we want to run our file to do the analysis. Nice. So I don't know how long this should take, probably not too long. Okay, cool. All right. So now let's go look at our data. And what did we call this? Oh, classifier results. Okay, nice. So we got, hi buddy. We got positive returns on most years. We went negative in 2015 and 2020 and 2021. And that's training on all previous years. So we could put this into the PowerPoint as well. And it looks nicer if we just pull it up in the terminal. So let's do that. Import pandas as PD. PD.read, so we want to read our CSV file. And so let's put the name of that here. Classifier results.csv. Cool. I guess it didn't do the set index. I have to fix that. Okay. Now this gives the returns for each year. Okay. Now, put that into our PowerPoint. All right, implemented nearest neighbors classifier. Numbers are returns from 2008 to 2021 using classifier using all previous seasons as training data. Okay, numbers are returns using all previous seasons and training data with classification threshold of 0.95, I think is what we were using. Classification threshold, yep, 0.95. So let's go back to the PowerPoint. Is there anything else we need to note here? No. I think we're doing pretty good. We're going to go back to the Trello board. Now let's see, generalized classifier. Haven't cleaned up the code yet. Let's go do that now. May as well while we're here. So let's delete everything we don't need. Just start at the bottom and work up. Don't need any of that. Don't need that. Don't need that. Oh, actually we do everything that we just deleted. Oh no, we don't need that. But the other stuff we do. All right, now let's go up here. Get rid of that line. Get rid of this. Get rid of the bounds definitions that we fixed at the beginning of this stream. Get rid of this stuff. Get rid of the region parameters that we had a long time ago. Get code. Already wrote that code. Don't need these lines. Returns a polygon defined by the 4 points from returns a polygon defined by the region, type, and parameters. Okay, now this we don't need. Up, 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 up. We like all that, all those comments. That's not a function, so we can get rid of that. Let's go down, make sure this all looks good. I think there might be another function towards the bottom that doesn't do anything. Right here. Test classifier seasons isn't a function. Get training years plot. Nice. And that we don't really need. Okay. So that's cleaned up our code. Can move this to done. Move to done. All right. Now we want to generalize the classifier so that we could use different types of classifiers and different parameters. And then mess around with classifier parameters to try to get positive results for all seasons. And the priority on that obviously is high priority because that's what we want to do next. Okay. So that's the end of this stream. Thanks for watching. Next stream we'll keep working on the classifiers, and hopefully we'll be able to have a strategy that works. So, thanks for watching. Goodbye.